The Soviet Union really did adopt a tank, without a gun. It was called the weapon of the future, and they were certain it would forever change tank warfare. This machine could destroy armored vehicles with a first-round hit from several kilometers away. But just a few years later, it was practically abandoned. What was the reason? What critical flaw undermined this revolutionary project? And why are many of this unusual tank's technologies still in use today? All of this is covered in today's episode. Imagine a tank that looks like a standard Soviet combat vehicle, confidently moving across rough terrain, with powerful armor capable of accompanying advancing units. But at the decisive moment, something unexpected happens. Instead of the familiar roar of a tank gun, a compact launcher slowly rises from the turret, and a guided missile streaks toward the target. No long barrel, no familiar gunshot. Just a few seconds, and the missile flies precisely to the target. This is exactly how one of the most unusual projects in Soviet tank design looked in the late 1960s. If you're interested in tanks, secret military projects, and forgotten war machines, be sure to subscribe to the channel and turn on notifications. There are many more fascinating stories ahead. Enjoy the video, and let's continue. For its time, the IT-1 made an almost fantastic impression. Many foreign specialists initially simply did not believe that the Soviet Union had adopted a full-fledged tank that completely abandoned a gun. Before this, such vehicles existed only as experimental prototypes. But here, we were talking about serial equipment officially delivered to the troops. At first glance, the idea seemed flawless. If a modern guided missile can reliably hit armored vehicles at a distance of several kilometers, why continue using a heavy gun that takes up a huge amount of space inside the turret? Why carry dozens of massive shells if they can be replaced by a significantly smaller ammunition load of precision weapons? This was precisely the question that Soviet engineers began asking themselves in the early 1960s. The IT-1 was built on the basis of the well-proven T-62 tank, which was already considered one of the most modern vehicles in the Soviet army. This meant that the developers did not have to create a new engine, transmission, or running gear from scratch. The vehicle received a proven V55A 12-cylinder diesel engine with 580 horsepower. Such a power plant allowed the combat vehicle, weighing about 35 tons, to reach speeds of up to 50 kilometers per hour on highways and to confidently move across difficult terrain alongside conventional tank units. Protection remained an equally important advantage. The hull almost entirely retained the design of the T-62, with rational angles of inclination for the armor plates. The upper frontal plate had a thickness of about 100 millimeters, positioned at a steep angle, which significantly increased its effective resistance. The front of the turret was a massive cast structure of variable thickness, providing a high level of protection against most anti-tank weapons of its time. At the same time, the absence of a long gun unexpectedly reduced the likelihood of damage to the main armament when moving across rough terrain or in tight urban environments. Even the crew was smaller than in most tanks of the previous generation. Instead of 4 people, the vehicle carried only 3: a driver mechanic, a commander, and an operator gunner. This solution made it possible to use the internal volume of the hull more efficiently and to free up space for a completely new weapons system that had not existed on any serial Soviet tank before. From the outside, it seemed that Soviet engineers had finally found the ideal formula. The vehicle retained the protection of a medium tank, had high mobility, required a smaller crew, and instead of a conventional gun, it received a weapon that promised to hit any existing armored vehicle with the first hit. Many military analysts seriously assumed that the future of tank forces lay precisely with such vehicles. But history very quickly showed something surprising. Just a few years later, they began to gradually abandon this seemingly flawless concept. Moreover, the Soviet designers themselves came to the conclusion that they had conducted an extremely important experiment, which proved not at all what they had initially expected. To understand why such a promising vehicle could not change the history of tank design, one must first understand what exactly was happening in the world of weapons in the early 1960s, and why engineers suddenly decided that the conventional tank gun was beginning to give way to an entirely new weapon. In the early 1960s, the world of tanks stood on the threshold of serious changes. For several decades, the main indicator of combat effectiveness had been the power of the gun. Designers constantly increased caliber, raised the initial velocity of shells, improved armor-piercing ammunition, and strengthened the armor of the vehicles themselves. It seemed that this race would never end, but it was at this very moment that guided anti-tank missiles began to assert themselves ever more confidently on the battlefield. The first generations of anti-tank systems were far from perfect. They required highly trained operators, were sensitive to weather conditions, and did not have a high probability of hitting. However, within just a few years, the situation began to change rapidly. New control systems significantly improved accuracy, and the missiles themselves received shaped charge warheads that virtually no longer cared how thick the target's armor became. If a conventional armor-piercing shell had to literally punch through metal with its kinetic energy, a shaped charge formed a high-velocity metal jet capable of burning through armor several hundred millimeters thick. For tank designers, this looked almost revolutionary. Until then, increasing protection required simultaneously increasing the vehicle's mass, installing a more powerful engine, and strengthening the running gear. Now a means of destruction appeared that allowed a relatively small missile to deal with armor that had previously required heavy, large-caliber guns. It was then that the question began to be asked more and more often. If a missile hits a target more effectively than a gun, then why continue building a tank around a long barrel? After all, a classic tank artillery system took up a huge amount of space inside the turret. The breech of the gun recoiled almost half a meter after each shot, so the size of the fighting compartment had to be increased. Around it were placed recoil mechanisms, aiming mechanisms, a massive cradle, and ammunition storage spaces. A single unitary round for the Soviet 115mm smoothbore gun was almost a meter long and occupied a significant internal volume of the vehicle. In addition, each artillery shot was accompanied by powerful recoil. To compensate for it, reinforced mounts, a strong turret, and complex hydraulic recoil mechanisms were required. All this increased the tank's weight and complicated its design. The missile launcher experienced virtually none of these loads. During launch, the rocket engine began accelerating the missile only after it had left the guide, so the impact on the vehicle itself remained minimal. This opened up the possibility of creating more compact turrets and making more rational use of internal space. Equally tempting were the prospects of increasing the range of engagement. For most tank guns of that time, The most reliable engagement of moving armored targets was expected at ranges of about 1.5 to 2 kilometers, and much depended on the crew's skill, the quality of the site, and weather conditions. A guided missile promised to change the very philosophy of combat. Instead of calculating a complex ballistic trajectory, the operator had to keep the target in sight, and the control system would guide the missile to the meeting point with the enemy. Theoretically, this made it possible to hit armored vehicles at significantly longer ranges than the effective firing range of a conventional gun. Engineers were also attracted by the possibility of reducing the vehicle's silhouette. Without a long barrel, the tank became less visible when moving through forest belts, was easier to camouflage behind folds in the terrain, and did not risk catching the gun on obstacles when maneuvering. The freed-up volume could be used for an automated ammunition feed system, additional equipment, or reducing the overall height of the turret. At the same time, ideas about future war were also changing. Many military specialists assumed that the main tank battles would take place over large open spaces in Europe, where armored vehicles would be able to detect each other from several kilometers away. In such conditions, the advantage went to whoever detected the target first and delivered an accurate strike. That is precisely why a guided missile seemed almost like the ideal weapon of the future. It combined long range, high probability of hitting, and a powerful shaped charge warhead that did not require constant increases in caliber. By the mid-1960s, this idea had so captured Soviet specialists that discussions gradually ceased to be purely theoretical. In the design bureaus, they no longer discussed whether it was worth creating a missile tank. Now the main question was quite different. What should the first serial tank look like that would completely abandon the conventional gun and prove that an entirely new era of armored vehicles was beginning? When the decision was finally made, the designers were faced with an extremely complex task. They needed not just to replace a gun with a missile launcher, but to create a full-fledged combat vehicle that, in terms of protection, cross-country capability, and mobility, would be in no way inferior to an ordinary medium tank. Any loss of characteristics would mean that the new concept was initially losing to classical armored vehicles. The work was entrusted to a team that already had enormous experience in creating new generation tanks. The well-proven T-62 was chosen as the basis. This approach made it possible to significantly reduce development time, since the hull, power plant, transmission, and most of the running gear had already passed state tests and were being serially produced by industry. The new project received the factory designation Object 150. However, it quickly became clear that using a ready-made chassis did not at all mean building a new vehicle without serious modifications. First of all, the internal layout of the turret had to be completely changed. The huge breech of the gun disappeared, but its place was immediately taken by mechanisms that had never before existed on Soviet tanks. It was necessary to fit an automatic feed mechanism for the long-guided missiles, a rotating launch device, radio command guidance equipment, numerous electronic units, and also to ensure comfortable work for the operator, who was now becoming the main person in battle. The hull itself retained its welded construction of rolled armor plates, but the distribution of internal space changed noticeably. The freed-up volume was used as rationally as possible. The ammunition was placed closer to the center of the vehicle, which made it possible to reduce the effect of hull oscillations on the operation of the automatic mechanisms and at the same time improved weight distribution. This solution had a positive effect on ride smoothness over rough terrain and reduced the load on the front road wheels. The running gear was transferred from the T62 with virtually no changes. On each side, 5 large road wheels with individual torsion bar suspension were installed. The first and last units received hydraulic shock absorbers, which reduced longitudinal pitching of the hull when moving at high speeds.
Tracks with metal joints provided good traction on both hard ground and loose soil, and the track width of about 580 millimeters allowed maintaining a relatively low ground pressure. The mechanical transmission also did not have to be changed. It included a 5-speed gearbox with reverse, 2-speed final drives, and time-tested steering mechanisms. Thanks to this, crews who had already mastered the T62 could be retrained on the new vehicle relatively quickly, without having to completely change their familiar driving skills. Much attention was paid to the hull's sealing. The vehicle retained equipment for protecting the crew from weapons of mass destruction, a filtration ventilation unit, and an automatic fire suppression system. For cold climate conditions, a standard engine preheater was provided, and the 24-volt electrical system ensured power for numerous new electronic devices, even during prolonged stationary operation.
The engineers understood perfectly well that they were creating a vehicle of a completely new class. Therefore, a margin of reliability was built into literally everything. Any malfunction in the automatic systems could leave the crew without their main armament, so each mechanism underwent repeated endurance tests, simulating thousands of kilometers of travel over rough terrain, strong vibrations, shocks, and sharp temperature changes. Gradually, the experimental Object 150 began to take on a finished appearance. But the most unusual solution was not inside the hull, nor even in the power plant. It was hidden in the turret. It was this part of the vehicle that amazed even experienced tankers who saw the new Soviet tank for the first time. If you looked at the IT-1 from a distance, you might not immediately understand how it differed from other Soviet tanks. Only upon closer inspection did it become noticeable that the vehicle had no conventional long barrel at all. Instead, the engineers created one of the most unusual turrets in the history of world tank design. The turret was a low-cast structure with a maximally reduced silhouette. Its shape was carefully calculated not only from the point of view of protection, but also to reduce the vehicle's visibility on the terrain. The lower the tank's height, the easier it was for the crew to use natural folds in the terrain, showing the enemy only a small part of the turret. In fact, most of the hull could be hidden even behind a relatively low obstacle. The main feature was a fully retractable launcher. In traveling position, it was located inside the turret and was covered from above by a massive armored hatch, almost merging with the turret's surface. While the vehicle was moving, it was almost impossible to determine where the armament was located. This scheme simultaneously protected the mechanisms from fragments, dirt, precipitation, and significantly reduced the likelihood of accidental damage to the equipment. Before opening fire, the entire process took place automatically. First, the armored hatch slid to the side. Then, a special hydromechanical drive raised the guide rail into combat position. Simultaneously, the automatic loader fed the next missile precisely onto the launch beam. Only after numerous sensors confirmed the correct position of all mechanisms did the system allow the launch to be performed. After the missile was launched, the cycle repeated in reverse order, and within a few seconds, the launcher was again completely hidden inside the turret. This entire sequence required exceptionally precise operation of the mechanisms. Even a slight misalignment of the drives could lead to skewing of the guide rail or incorrect installation of the missile.
Therefore, the engineers used a system of numerous limit switches, mechanical latches, and interlocks that prevented the next stage from beginning until the previous one was fully completed. The automatic ammunition feed mechanism proved particularly challenging. Unlike a conventional artillery round, the missile had a significantly greater length and a different center of gravity. The automatic mechanism had to carefully extract it from the stowage, rotate it into the required position, and place it on the guide rail without the slightest impact. For this purpose, special guide rollers, damping elements, and mechanical grippers were used to reduce vibration when the vehicle operated on uneven surfaces. The main mechanized stowage held 12 missiles. A few more were stored separately in a non-mechanized stowage and could replenish the automatic mechanism after the main ammunition load was expended. This solution made it possible to keep the turret relatively compact and at the same time provide a fairly serious supply of guided weapons for several consecutive combat episodes. Despite the abandonment of the gun, the tank was not left completely without conventional weapons. To the left of the launcher was a coaxial PKT machine gun of 7.62 mm caliber. Its ammunition load consisted of several thousand rounds in belts, which made it possible to conduct sustained fire against light targets, unarmored vehicles, and enemy personnel, where the use of an expensive guided missile would be completely pointless. The operator's workstation also differed greatly from a conventional tank position. His main task now was not simply to aim the weapon, but to continuously track the target throughout the missile's entire flight. Therefore, special attention was paid to the placement of controls, the comfort of the handles, visibility, and the stability of the sighting line. A few movements of the operator's hands directly determined whether the missile would hit the target precisely at a distance of several kilometers. From the outside, everything looked almost flawless. The turret concealed the armament until the last moment. The automatic mechanisms performed dozens of operations without crew involvement, and the vehicle itself retained a low silhouette and good protection. It seemed that the engineers had indeed managed to create a new generation tank. But this entire complex structure existed solely for one element, which was supposed to justify the entire project. That element was the Dragon-guided missile. The main weapon of the new vehicle was the 3 M7 Dragon guided anti-tank missile, developed specifically for the 2K4 system. Unlike most existing anti-tank systems at the time, here the missile and the tank were initially designed as a single system. The designers did not try to adapt an already finished projectile to the new vehicle. They developed the entire system simultaneously, ensuring that each element worked as part of a single mechanism. In terms of size, the missile differed significantly from a standard tank round. Its caliber was about 180 millimeters, and its mass approached 50 kilograms. Inside were placed a shaped charge warhead, a sustainer motor, steering actuators, radio command reception equipment, and control system elements. Despite its impressive dimensions, the missile remained compact enough for the automatic loader to move it quickly inside the turret. After pressing the launch button, the starting charge fired, carefully ejecting the missile from the guide rail. Only at a safe distance did the sustainer motor ignite, accelerating it to a speed of about 200 meters per second. This scheme significantly reduced the load on the launcher itself and eliminated the destructive effect of the jet exhaust on the vehicle's turret. The most complex element of the system was the guidance system.
It operated on a semi-automatic principle of radio command guidance. The operator no longer had to manually correct every movement of the missile as on earlier anti-tank systems. His task was to keep the sight's crosshairs constantly on the target. Everything else was handled by the equipment, which calculated the missile's deviation from the line of sight and transmitted the necessary commands to it via a secure radio channel. The effective firing range was approximately from 300 to 3,000 and, under certain conditions, reached about 3,300 meters. For the late 1960s, this looked like a very significant advantage. At such ranges, not every tank crew could guarantee a hit with a conventional armor-piercing round on the first shot, especially against a moving target. Here, the probability of successful engagement was significantly higher due to constant trajectory correction. The capabilities of the shaped charge warhead were equally impressive. It provided penetration of several hundred millimeters of homogeneous armor regardless of firing range. Unlike a kinetic projectile, which gradually lost velocity and penetration as range increased, the effectiveness of a shaped charge was practically independent of the distance at which it met the target. This is precisely why the IT-1 was particularly dangerous at long ranges, where conventional tank guns were already beginning to lose out in terms of hit probability. The sighting system also formed an important part of the overall concept.
For the operator, a stabilized line of sight was created, allowing the target to be tracked even while the vehicle was moving. The system accounted for hull oscillations caused by suspension operation and helped keep the sight on the enemy's armored vehicles. All this significantly reduced the influence of the human factor and turned the firing process itself into a complex joint effort of man and electronics. On paper, the IT-1 looked like an almost ideal weapon for tank duels. The vehicle detected a target, took up an advantageous position, launched a precision missile, and hit the enemy before they could get within their own gun's confident engagement range. It seemed that this was exactly how all future tanks would look. But there was one problem that could not be seen in the technical specifications. Any combat vehicle is only good as long as it operates under the conditions for which it was designed.
As soon as real combat went beyond the designer's calculations, the advantages began to gradually turn into serious limitations. The concept of the IT-1 was built around one simple idea: do not let the enemy get close. As long as the distance remained large, the vehicle indeed looked extremely dangerous. The low silhouette allowed the use of terrain folds, the guided missile worked reliably over several kilometers, and the crew could quickly change position after a launch without engaging in a protracted firefight. It was precisely under such conditions that the new tank fully justified its creators' expectations. However, war rarely develops according to a pre-written script. The first calculations already showed that there was a kind of zone around the vehicle where its main weapon was virtually useless. The minimum range for missile use was about 300 meters. Up to this distance, the guidance system simply did not have enough time to fully guide the missile onto the line of sight. If the enemy sharply closed the distance, the IT-1 suddenly lost its main advantage. In effect, the crew was left with only the coaxial machine gun. Against another tank, such armament was powerless. The only way out was maneuver, an attempt to break the distance or finding cover. The vehicle, created as a tank destroyer, unexpectedly found itself extremely vulnerable in close combat. Another limitation was the ammunition load. 15 guided missiles seemed like an impressive supply only at first glance. In conditions of a short ambush operation, this was indeed sufficient. But in a protracted engagement, ammunition consumption occurred much faster than initially calculated. After the mechanized stowage was expended, the crew had to manually replenish the automatic mechanism, and such an operation required time and could not be performed under heavy fire. Serious demands were also placed on operator training. The semi-automatic system made aiming easier, but did not relieve the operator of the need to constantly track the target. If the enemy tank sharply changed direction of movement, hid behind a smoke screen, crossed terrain folds, or temporarily disappeared from sight, the probability of successful engagement dropped noticeably. Any loss of visual contact could ruin the attack. Additional difficulties were created by weather conditions. Heavy rain, dense dust, smoke after artillery bombardment, or thick fog impaired the operator's visibility. Unlike modern thermal sights, which did not yet exist at the time, the entire system depended entirely on the quality of optical observation. The worse the operator saw, the harder it became to keep the target locked until the moment of impact. Gradually, another problem emerged that had initially been given little thought. Any classic tank had a wide range of ammunition. Armor-piercing shells were used against heavy equipment. High-explosive fragmentation shells destroyed fortifications, engaged anti-tank weapon crews, and helped clear the way for advancing infantry. Smoke rounds allowed covering unit maneuvers. The IT-1 was practically deprived of such versatility. Its missile excelled against armored vehicles, but was by no means always the optimal means against other targets. As a result, commanders increasingly came to an unexpected conclusion. A tank's most valuable feature is not at all its maximum effectiveness against one specific target. Much more important is the ability to act equally confidently in a wide variety of situations. It was here that the missile tank concept first began to lose out to the traditional gun-armed combat vehicle, despite all its impressive technical capabilities. Despite the identified shortcomings, the IT-1 project itself cannot be considered a failure. On the contrary, it was this vehicle that forced Soviet industry to solve problems that had not previously existed. In essence, it was necessary to simultaneously combine the achievements of several branches of industry at once: tank building, instrument making, radio electronics, and missile technology. Each of them gained invaluable experience that was later used in the creation of completely different combat vehicles. The work on the automatic mechanisms proved particularly challenging. Before the IT-1, Soviet automatic loaders handled relatively compact artillery rounds, but now it was necessary to carefully handle a long guided missile. Any misalignment during feeding could put an expensive round out of commission even before launch. Therefore, the engineers developed a system of guides, latches, and dampers that reduced shock loads when the vehicle moved over rough terrain. During testing, the mechanism was repeatedly checked after long marches over cobblestone roads, sandy sections, and deep ruts, achieving stable operation even under severe vibration. A separate task was ensuring the reliability of the numerous sensors. Practically every stage of launch preparation was controlled automatically. The equipment checked the position of the armored hatch, the locking of the guide rail, the correct installation of the missile, the readiness of the guidance system, and the condition of the electrical circuits. As long as at least one element did not confirm its serviceability, the launch command was blocked. This principle of built-in self-check later became common for many modern armored vehicles. But in the mid-1960s, such automation looked very advanced. No less attention was paid to the electronics. Inside the tank, a diesel engine, generator, radio station, turret electric drives, and sensitive guidance equipment all operated simultaneously. All this created electromagnetic interference that could distort the radio commands transmitted to the missile. To solve the problem, cable networks were separated by function. The most important lines were shielded, and control units were equipped with filters that reduced the effect of electrical interference. Thanks to this, the system's stability during operation was significantly improved. Work also continued on the crew's workstations. The designers tried to reduce the number of unnecessary movements for the operator, since tracking a target sometimes had to be maintained for several seconds in a row, keeping it in the center of the site with virtually no errors. The controls were made as smooth as possible. The force on the handles was carefully selected experimentally, and the arrangement of instruments was changed until the operator could work with virtually no change in body position. It was precisely these, at first glance, unnoticeable solutions that later became the basis for the ergonomics of many Soviet combat vehicles. Much attention was paid to personnel training. For the IT-1, special training stands and simulators were created that simulated tracking moving targets. Future operators spent hours practicing keeping the crosshairs on armored vehicles moving at different speeds and along various trajectories. Exercises with smoke screens, sudden disappearance of targets behind terrain folds, and head-on movement appeared. All this was necessary because even the most advanced technology remained dependent on human skill. The most interesting thing was that many of the solutions outlived the IT-1 itself. The increased requirements for vibration resistance of equipment, the culture of built-in control, the automation of firing preparation, the principles of placing electronic units, and even the approaches to organizing crew workstations later appeared in completely different projects. Paradoxically, the vehicle had not yet become widespread, but its technical legacy had already begun to live its own life. The real test of the new concept was to come not from the designer's calculations or factory tests, but from Army field operations. It was there that it became clear how well the elegant engineering solutions matched the real battlefield. During field trials, the IT-1 initially made a very strong impression. In open terrain, where targets were detected in advance, the vehicle demonstrated precisely the qualities for which it was created. Using the low height of the hull and turret, the crew took up a prepared position, leaving the enemy only a minimal area to target.
After target detection, a launch was made, and almost immediately the vehicle changed position, not lingering under possible return fire. At such ranges, the system's advantages were fully realized. The enemy was just preparing to open fire, while the guided missile was already on its trajectory. Particularly highly valued was the ability to achieve a first-round hit without prolonged zeroing, which was often required when using conventional tank artillery. For defensive operations, such tactics proved highly effective, but as soon as conditions became more complex, the picture gradually changed. In rugged terrain, the target regularly disappeared behind hills, tree lines, or buildings. In urban conditions, ranges sharply decreased, and target detection time shrank to a few seconds. In wooded areas, the large number of natural obstacles constantly disrupted the line of sight, without which the use of guided missiles became extremely difficult.
The military quickly noticed another feature. As long as the IT-1 was engaging tanks, its effectiveness indeed remained high. However, during actual tactical exercises, crews regularly had to deal with targets against which using an expensive guided missile was simply uneconomical. Anti-tank crews in foxholes, machine gun emplacements, light fortifications, buildings occupied by the enemy, All these tasks a conventional tank solved with a few high-explosive fragmentation rounds. The IT-1 crew had virtually no such choice. Gradually, one thought appeared more and more frequently in the testers' reports. The vehicle excelled at a narrow range of tasks, but modern combat required significantly greater versatility. A unit commander could not know in advance exactly what targets would be encountered in a few minutes. That is precisely why a tank must be equally capable of engaging armored vehicles, fire points, light fortifications, and enemy personnel. These conclusions turned out to be far more important than individual technical remarks. They effectively called into question the entire philosophy of a tank armed exclusively with guided missiles. By the end of the 1960s, the IT-1 was officially adopted into service, but it never became widespread. Serial production continued for a relatively short time. According to various sources, approximately between 100 and 200 vehicles were manufactured. For Soviet industry, which produced tanks in the thousands, this was very little. Soon it became obvious that the further development of armored vehicles would follow a completely different path. No one was going to abandon the idea of guided missiles themselves. On the contrary, they had proven their high effectiveness. But now the designers decided not to replace the gun with them, but rather to supplement it with new capabilities. This is how the concept that later became classic emerged. The main armament once again became a universal tank gun, capable of firing armor-piercing, sub-caliber, shaped charge, high-explosive fragmentation, and other types of ammunition. At the same time, through the gun barrel, it became possible to launch guided missiles against the most complex targets at long ranges. This approach combined the advantages of both systems and virtually eliminated their main drawbacks. In essence, the IT-1 became a large-scale experiment. It did not fail because of poor design, weak armor, or insufficient mobility. On the contrary, the vehicle fully confirmed the functionality of most of the technical solutions. What proved erroneous was the very idea of building a tank around a single type of weapon. And yet, the significance of the IT-1 is difficult to overestimate. It was this vehicle that proved that the automated feeding of guided ammunition was entirely feasible.
It was this vehicle that showed how important built-in diagnostic systems, protected electronics, and a high culture of instrument equipment design were. It was on this vehicle that the issues of human interaction with a complex electronic weapon control system were first worked out so deeply. That is why today, specialists view the IT-1 quite differently than several decades ago. It is no longer just a rare Soviet tank without a gun, nor just another unusual experiment from the Cold War era. It is one of those vehicles that did not become widespread, but nonetheless managed to change the very direction of armored vehicle development. Sometimes it is precisely such projects that prove to be the most valuable. They do not set records for the number of units produced and do not become symbols of an era. Their task is quite different: to show designers the boundaries of what is possible, to indicate a path not worth repeating, and at the same time to bequeath technologies without which the next generation of combat vehicles is impossible to imagine. The IT-1 had a relatively short service life, but its influence proved to be far longer than its own history. While some remembered it as a tank without a gun, others saw in it the first serious attempt to look into the future of tank forces.